Welcome to the deep dive. Ready to get our minds blown today? We're diving into the scale of things like how insanely huge the universe is, or like how incredibly tiny atoms are. It's kind of crazy to even think about.
Yeah, it's hard to wrap your head around.
Right. Like we're going to look at all sorts of stuff, from tiny little atoms to massive galaxies, and we'll use comparisons to help us understand it all.
It's really interesting, when you compare things that are vastly different in size, you can start to understand them better, like using something familiar as a reference.
Exactly. Like how would you explain $1 billion to someone who's never seen that much?
Yeah,
You need those comparisons. So are you ready to get started?
absolutely.
Okay, let's jump right into the microscopic world.
All right, so imagine you could blow up an atom to the size of a football stadium.
Whoa, okay, I'm picturing that. A huge stadium. Then what?
So the nucleus in the middle of that atom, it'd be like a teeny tiny marble just sitting there on the 50-yard line.
Wow, so like all that space in the stadium is pretty much empty,
Mhm.
just like inside an atom.
Exactly. And the electrons would be zipping around somewhere up in the stands, super far from that marble-sized nucleus. It really shows you how much empty space there is inside atoms.
That's wild. And to think everything around us is made of those tiny things.
It's pretty mind-blowing, right? And to add to that, just a single grain of salt, like the kind you put on your food,
Yeah, okay.
it actually has more atoms in it than there are stars in the Milky Way.
Hold up, wait a second. Are you serious? That tiny little speck of salt has more atoms than all those stars we see at night.
Yeah, it's a pretty crazy thought. It really shows you just how densely packed matter is at the atomic level.
Okay, wow. My mind is already starting to bend a little.
But hey, it's a good bend.
Yeah, it is. Okay, so we talked about atoms, but what about DNA?
Oh yeah, DNA. Well, imagine taking all the DNA from just one cell in your body and stretching it out completely.
Okay, I'm stretching it in my mind. How long is it?
It would be over 6 feet long, taller than most people.
Wait, each tiny cell has a strand of DNA longer than I am. That's insane.
Yeah. And all the instructions for building and running a whole human are packed into that teeny tiny space. It's really incredible.
Before we move on, what about viruses? Those are microscopic, right? How small are they compared to, say, bacteria?
Okay, think of it this way. A virus is as small to a bacterium as a human is to an entire city block.
Whoa. Okay, that puts things into perspective.
Right, it makes you realize there are whole worlds existing on scales we can barely imagine.
Okay, that was a wild ride through the microscopic world.
Yeah, pretty tiny stuff.
So now how about we zoom in a bit to, well, us, humans. I mean, our bodies are pretty amazing too, right?
Absolutely. For instance, our brains, did you know all the neurons in your brain, if you line them up, could circle the Earth 4 times?
You're kidding, right? All those neurons could wrap around the entire planet 4 times.
Yeah, it's wild. We're talking trillions of connections packed into something smaller than a basketball.
Now here's another crazy thought. Our bodies replace like 98% of their atoms every single year.
Yeah. Basically, we're practically new people every year, at least at the atomic level. It's amazing how dynamic and constantly changing our bodies are.
It's a lot to take in. So what other hidden wonders are inside us?
Well, get this. If you spread out the surface area of your lungs, it would cover a whole tennis court.
Seriously,
Yeah.
all that fits inside my chest. That's a lot of surface for breathing.
And if that's not impressive enough, your blood vessels, if you laid them all out end to end, could circle the Earth 2.5 times.
Whoa, that's a massive network. And speaking of networks, we can't forget the microbiome.
Right, all those bacteria and microorganisms living in and on us.
Yeah, I've heard we have a ton of them.
More than you might think. There are 10 times more microbial cells than human cells in your body.
Hold on, you mean we're more bacteria than human?
In a way, yeah. They play a crucial role in our health, though, helping us digest food, boost our immune systems, and even affect our moods.
So we're like walking ecosystems. That's both fascinating and a little creepy. Okay, we've gone from atoms to our own bodies. What about the stuff beyond our planet?
Time to expand our horizons to planetary and galactic scales. Get ready for a cosmic journey.
Bring it on. I'm ready for some serious perspective changes.
Okay, let's start with Earth. Its diameter is about 12,742 kilometers. Now imagine light traveling across that distance. It takes about 7.5 seconds for light to cross the entire Earth.
Wow, so light can zoom across our planet faster than I can finish my coffee. That's amazingly fast.
It really is. Now let's talk about time. Earth is about 4.5 billion years old. To put that into perspective, imagine squeezing Earth's whole history into just one day.
Okay, so Earth forms at midnight.
Exactly. Then, for billions of years, only single-celled organisms are around. Dinosaurs don't show up until almost 11:41 p.m., and they're gone right before midnight.
You're kidding. So all of human history happened in the last few seconds of that day.
Actually, humans appear in the last 2 seconds of that day.
Wow, that's... I don't even know what to say. It really makes you feel pretty small in the grand scheme of things.
It definitely puts things in perspective. And we think of human history as this long period, but compared to Earth's history, it's nothing.
So we've barely had time to make a mark on the universe.
Yeah.
Speaking of making marks, we've dug pretty deep into the Earth, haven't we?
We've tried, but the deepest mine we've ever dug is only about 0.2% of the Earth's diameter.
Wait, with all our technology, we've barely scratched the surface. There's still so much to discover right under our feet.
Totally. We've explored more of outer space than we have our oceans or Earth's interior.
That's incredible, so much to explore. Okay, we've covered the microscopic, ourselves, and now Earth, ready to head outward, past our planet.
Now things get truly mind-boggling.
I'm ready. Bring on the cosmic perspective shifts.
All right, let's zoom out to our solar system in the Milky Way galaxy. Imagine our sun as a grain of sand on a beach stretching for 20 kilometers. That's the scale we're talking about.
So our sun, which seems huge to us, is just a speck in the Milky Way. Makes you feel pretty small.
It does, doesn't it? And we're just getting started. Let's talk about black holes. The one at the center of our galaxy is insanely massive. It's like comparing a single atom to the biggest skyscraper on Earth.
Whoa, okay, that size difference is hard to even imagine.
Yeah.
So if our solar system is a grain of sand, then this black hole is like a whole city.
It's truly immense, and it reminds us that there are forces and objects in the universe that are so powerful, so massive, that they're beyond our everyday understanding.
I'm definitely feeling the limits of my imagination here, but I'm loving it. What else you got?
Okay, how about the age of the universe? We condensed Earth's history into a day, right? But let's go even bigger. Imagine squeezing the universe's whole 13.8 billion year history into 1 year.
Got it. Big Bang happens at midnight on January 1st.
Right. Now, fast forward. Our solar system doesn't form until early September. And humans, we don't show up until the last 15 minutes of December 31st.
Wow, we really are late to the party. Makes you wonder what was going on for all those billions of years before us.
It does, doesn't it? But our late arrival doesn't make us any less remarkable. It highlights just how much happened in the universe before we even existed.
This is all giving me a sense of awe, mixed with a bit of existential dread. But in a good way.
It's all inspiring, isn't it? And there's so much more to explore. Ready for some truly mind-blowing comparisons?
You know me. Hit me with those extreme characteristics of the universe. What do you have?
Have you heard of neutron stars?
Yeah, I think so. They're those super dense stars, right? I don't really know much about them, though.
They are incredibly dense. Imagine a teaspoonful of neutron star material. That tiny amount would weigh as much as Mount Everest.
No way. A single teaspoon weighing more than a mountain. That's impossible.
It sounds impossible, but it's true. Neutron stars are what's left after giant stars collapse, and their density is unlike anything we see in our everyday lives.
Okay, my brain is officially fried. But I need more.
All right, let's talk about speed. We know light is fast, but have you thought about how fast it is compared to walking? In the time it takes you to take one step, light could circle the Earth 7 times.
7 times. I don't even have words.
It's an insane speed difference. It shows the huge gap between the scales of the universe and our normal experiences.
I think that's a good place to pause for now. My brain needs a minute to catch up.
Welcome back to the deep dive. Hopefully your brains have had a minute to reboot after all those comparisons.
Yeah, I think I've got most of the pieces back together, at least for now.
Mm-hmm.
It is kind of addicting, though, getting your mind blown like that, like seeing the world in a whole new way.
It really is. And guess what? We have a lot more to explore. Ready to dive back in.
Absolutely. Hit me with those mind-blowing comparisons.
Okay, let's switch gears and talk about technology, specifically miniaturization. Like, the transistor density on a modern computer chip is about the same as the number of cells in a human body.
Wait, so you're telling me a tiny computer chip is as complex as our whole body? And I used to struggle to fit my computer in a backpack.
It's crazy, right? It shows you just how good we've gotten at understanding and manipulating matter at incredibly tiny scales.
Makes you wonder what's next for computing. If we can pack that much onto a chip now, where will we be in 10 years?
That's a great question. Speaking of complexity, have you thought about how much data we're creating these days? Did you know that every 2 days we generate more data than all the data in human history up to the year 2000?
Hold on. Every 2 days? That's insane. Yeah, there are new apps and platforms all the time, and everyone's constantly sharing stuff online. But more data in 2 days than in all of history before 2000. That's a lot to process.
It is mind-boggling. We're living in an age of information overload. Makes you wonder where we'll store all that data and what it means for the future.
Definitely something to think about. Okay, hit me with some more mind-blowing comparisons.
All right, let's go back to the really big stuff. Our sun. Did you know it can take a photon, like a tiny particle of light, up to 100,000 years to travel from the sun's core to its surface?
Wait, what? I thought sunlight took about 8 minutes to reach Earth? How can it take that long to get out of the sun?
It does seem strange. But the sun's core is so dense and hot that the photons are constantly bumping into other particles. They have to take a long and winding path before they finally escape to the surface.
Wow, so those rays of sunshine have been on quite a journey. Amazing to think about all that's happening inside the sun, generating light and energy.
It's an incredible process. It really shows the immense power and complexity of our nearest star.
Okay, back down to Earth for a minute.
hmm
We talked earlier about how little we've explored beneath the Earth's surface. But what about the other way, up into the atmosphere and space?
Good point. Let's talk about airplanes. The highest a commercial airliner usually flies is about 10 kilometers. Now, the International Space Station orbits Earth at about 400 kilometers. That's 40 times higher.
So when I look up at a plane, the space station is way above it. Wow, that puts things into perspective.
It really shows how vast space is, even just near Earth.
We've talked a lot about scale in terms of size and distance. What about time? How do we even begin to understand those vast stretches of time in the universe's history?
Okay, think about this. The universe is roughly 13.8 billion years old. Imagine shrinking that to just 1 year. On this scale, our solar system doesn't form until early September. The dinosaurs wouldn't show up until the last week of December.
So on that scale, most of the universe's history is just a blank slate. And then everything we know about happens in a flash at the very end.
Exactly. It's almost impossible to grasp how long those cosmic events actually take.
It makes you realize how precious our time here is. We need to make the most of it.
Absolutely. Now let's talk about something a little more down to earth. You know how much gas it takes to fill up your car, right? A space shuttle uses over 3.8 million liters of fuel just to lift off.
3.8 million liters. It's like filling an Olympic-sized swimming pool with rocket fuel.
It's massive. It just goes to show how much energy it takes to overcome Earth's gravity and get into space.
It makes you really appreciate the engineering and power behind space exploration.
Definitely. And it shows how challenging it is to make space travel more efficient and less resource intensive.
Okay, I think my brain needs a little break from all this cosmic perspective. What about some comparisons that are a little more well-grounded?
I hear you. Sometimes it's good to bring things back down to earth, even if it's just metaphorically. Ready for some amazing comparisons that are a bit closer to home?
Absolutely. Bring on the earthly wonders. Welcome back to the Deep Dive. My mind is still buzzing from all those incredible comparisons. It's amazing how thinking about scale can change how you see everything.
It really is. And we've got even more incredible comparisons to share.
All right, I'm all ears. Hit me with those perspective-altering insights.
Okay, let's talk about the internet. The amount of information flying around online every minute is mind-blowing.
I bet it is. I can barely keep up with my inbox.
Well, get this. It would take about 15,000 physical libraries to hold the same amount of data that's transferred online in just 1 minute.
15,000 libraries.
Yeah.
That's more libraries than I've ever seen. No wonder we feel overwhelmed with information sometimes.
It's a true information explosion, and it's only getting faster. It makes you think about how we can even filter and process all that data.
It's like trying to drink from a fire hose.
Uh,
All right, what else do you have? I'm ready for more.
let's go back to the microscopic world. Bacteria. They're everywhere, but have you ever thought about how much they all weigh?
Honestly, I haven't. I mean, they're so tiny. How much could they possibly weigh?
Well, brace yourself. The estimated weight of all bacteria on Earth is a massive 70 times the combined weight of all humans.
Wait, all those tiny bacteria weigh more than 70 times all the people on the planet. That's insane. It's like there's this hidden massive world we never even see.
It's incredible, right? It shows you just how much is going on that we usually don't notice, and it highlights how everything on our planet is connected.
Makes you realize humans aren't the only ones running things around here.
Right.
Okay, I need something a bit lighter after that one.
Okay, let's talk about sound. The quietest sound we can hear is about 0 decibels. But a rocket launching can reach 180 decibels. That's about 1 trillion times louder.
1 trillion times.
Yeah.
Wow, that's amazing. It's incredible how much our ears can pick up, from a whisper to a rocket launch.
It really is. And it makes you think about protecting your hearing from those super loud noises.
Definitely a good reminder. All right, one last mind-bending comparison before we wrap up.
Let's talk speed again. The fastest a human can run is about 45 kilometers per hour. Light travels at a mind-blowing 1.08 billion kilometers per hour.
Okay, so light is much faster than us. Got that.
Much, much faster. Light is over 24 million times faster.
24 million times.
Yeah.
Whoa. It's like comparing a snail to a rocket ship.
It's hard to even imagine a speed difference that big. It really puts the power and energy of the universe into perspective.
My brain has officially reached its limit for mind-blowing comparisons today. This deep dive has been an incredible journey. From the tiniest atoms to the vast universe, it's a reminder that there's always more to discover.
Totally. And it shows how we're all part of something much bigger than ourselves.
Couldn't agree more.
Hmm.
As we wrap things up, what's one last question to leave our listeners with?
How about this? If the universe is always expanding, what's it expanding into? It's a question that stumped scientists for ages. It makes you realize just how much we still don't know.
That's a great one. It reminds us to stay curious. So, listeners, keep those minds open, keep asking questions, and keep exploring. Thanks for joining us on this incredible deep dive into the mind-boggling scale of things.
Until next time, keep exploring.